Hi everyone, we have finished chapter 1 and chapter 2. Okay, so on our course website, you can see there is a final review. When you click that, you see this is a final review sheets for the whole semester, and we're at chapter 1, okay? So chapter 1, we talk about first order ODE. So section 1.3, we talk about the theorem of existence and uniqueness. Okay, it's about dy dx equals to f of xy and y of x0 is y0. So given the initial value problem, first of all, you have to make sure it's in the standard form. Standard form means your left-hand side has to be dy dx, okay? Then you set the right-hand side to be f, okay? You define it as f of xy. Okay, if f is continuous near the initial point x0, y0, then we get existence. If partial f, partial y is continuous near the initial point x0, y0, then we get uniqueness. Okay, so remember there are three types of conclusion. If f and partial f, partial y both continuous, they're both continuous, then we say a unique solution exists near the points x0, y0. Okay, if f is continuous, but partial f, partial y is not continuous near the point, we say existence but not uniqueness is guaranteed by the theorem near the point x0, y0. If both of them are not continuous near the point x0, y0, we would say neither existence nor uniqueness is guaranteed near the points x0, y0. Okay, so this theorem of existence and uniqueness it holds for all differential equations first order ODE. Okay, no matter which kinds. Okay, so that's why it works in general. That's good. So next, in order to actually solve the differential equation, we're very limited. We're only able to solve certain types of it. So 1.2 and 1.4, we talk about how to solve separable ODEs, okay, where we move all the y to the left-hand side and move all the x to the right-hand side, okay, and then you integrate both sides respectively, and you can plug in the initial value to solve the constant c. We also talk about some application problems like natural growth and the temperature problem and the compound interest problem. So make sure you review those application problems. And then section 1.5, we talk about linear first order ODE. So first of all, we have to make it into the standard form. What is the standard form? You have y prime and the y on the left hand side and the function of x is on the right hand side. So you're gonna make sure the coefficient of y prime is 1. Okay, so the standard form is y prime plus p of x times y equals q of x. Okay, so the integrating factor mu of x is then e to the integral of p of x dx. So p of x is the coefficient of y. Q of x is the function of x on the right hand side. And q of x does not contain y in it. Okay? And here be careful, if you have e to the 3 natural log of x, the 3 is actually becomes the power. X cubed is not like 3 times x. Okay, and then the formula is you use the integrating factor times y equals to the integral of the integrating factor times q of x dx. And usually here, the common mistake is student just integrates mu of x and q of x separately. No, don't do that. We don't have product rule. Integral of product is not product of integral. There must be a way that you can simplify mu of x and q of x such that you get something you are able to integrate. Of course, I hope that you can remember all the antiderivative formulas from Calculus 2. If you don't, you can go to our website. So I'm also teaching calculus 2, so you can go to that website and then you can find some worksheets and formula. Okay, let's continue. And then section 1.6, we talk about substitution. So in general, if you see the right-hand side is a composite function, you let v be the inner function g of xy. And then you solve y in terms of v, okay? And then you differentiate what is dy dx. And then you can see, you will see some dv dx over there, and then you can substitute, you can put in the ODE, and then you can get ODE about v. So you solve the new ODE, and then you plug the y back, okay? And the second type, we have homogeneous equation. Do you remember what is homogeneous equation? So that is all the terms, the total degree are the same. Like x squared, xy, y squared, the degree are 2, right? All the terms, they have the same degree. Then that is homogeneous equation. And for homogeneous equation, you can always express dy dx to be the function of y over x. Okay? And you let v be y over x. And then y is v times x. So remember here, we let v be y over x. We don't let v be x over y because we love product rule and we don't want quotient rule. Okay, then dy dx is v plus x times dv dx. So we plug in the differential equation, we get ODE about v, then this new ODE is either separable or first order linear. You can use the separable method or you can use the integrating factor method to solve it. The third case, the Bernoulli equation. So the formula of the Bernoulli equation will be given in the exam. So if you go to the practice exam, you can see this is the formula that I will provide you in the exam. We have the equation of Newton's law of cooling, and this is the formula after we solve the differential equation. And this is the Bernoulli equation, and this is the substitution. You let v be y to the 1 minus n. So make sure you have the standard form, okay? Figure out what's the n. And then you have the ODE for v, so your new p of x is actually 1 minus n times the old p of x, and your new q of x is actually 1 minus n times the old q of x. Okay, and then you can continue to use the integrating factor method to solve it. And 2.1, 2.2, we talk about autonomous ODE, where the right-hand side is only a function of y. Okay, so one type of problems is I will give you the autonomous ODE and ask you to sketch the solution curves. So first up, you find the critical point, and then you draw the phase diagram. So for example, here, you on the real number line, you plot the critical points, and those critical points are the equilibrium solutions. And then on each piece of the interval, you put some points into the ODE, and then you figure out your rate is positive or negative, and then your solution is increasing or decreasing. And then for each critical point, when you see solution are going away from it, then we know it's unstable. When you see solution are going towards it, we have stable. If one side you have solution going and the other side you have solution going out, then we have semi-stable. Okay? So when you draw the solution curves, make sure you draw it in a good shape that I'm able to see whether it's increasing or decreasing. So that means don't draw S shape or don't draw parentheses, okay? I should be able to see whether it's increasing or decreasing. I will also ask you if the solution curve passing through some initial points, what is the solution curve behave when t goes to infinity, okay? And for the applications, we have 3 types. The first type when is the general type. We have like the birth minus death. So you use the birth rate beta minus the death rate delta times p. Okay, so maybe I would tell you, okay, the beta is proportional to p, so your beta is like kp, and then your delta is 0, and then you can solve for it, or some other cases. Okay, so you can solve the ODE and work on the problem. The second type is the logistic model. So we have dp dt equals to kp times m minus p. So here, don't solve the ODE. The formula will be given in the exam. So see, the formula for logistic equation is given here. So you just need to read the story problem and figure out your p is 0, figure out the k and m. So use the information to solve k and m. So after you solve all those parameters, you can just plug in this formula. Okay. And then the third model, we have extinction and explosion equation. Okay, the formula also be given in the exam. Okay, so these two equations are the same. You can use either one. Okay, they are both correct. Okay, so you also need to figure out your k and p, 0 and m, and then you can plug in the numbers and then find p of t. Okay. And you can compare, actually those two formulas are very similar. This formula has a minus, and this one is without the negative, because those two equations are very similar, but now this k just become minus k in this case. Okay, so that is chapter 1 and chapter 2. When you have questions, feel free to email me. Don't forget to work on the practice exam, and also you can maybe look at your book and find some problems or make up some hard problems to practice. All right, bye.